Peter Malone from Pyro is here now to answer the most common queries that people raise. Peter, I know that the standard seal suits most applications, but you do offer a full range, so under what conditions would you use the others?
Well, the standard seal operates between -80 and 105 degrees centigrade, and this is generally sufficient for the vast majority of installations, but in addition we do have seals for high temperatures, nuclear applications, potentially explosive atmospheres, and of course for fire-resistant applications.
Well, it's certainly a comprehensive range. Now, what about glands?
Well, you only need one gland. The standard externally threaded gland is suitable for all the applications we've mentioned. However, where there are space limitations within the terminal box, Pyrotechnics can supply an internally threaded gland. This is called a space ranger, which comes in two sizes and covers the full range of popular light-duty cables.
And what insulation resistance should you expect after installation?
After both ends of the cable have been terminated, we would expect that the insulation resistance would be in excess of 100 megohms. However, initial low readings are not a cause for concern, and the insulation resistance should be noted and a second reading taken 24 hours later. A higher second reading indicates that the cable has been correctly sealed and the value should now be at least 100 megohms. If the value has not risen or has fallen, this indicates a fault condition and this should be located and rectified.
Well, if the reading isn't 100 megohms after 24 hours, what should be done?
There's a simple test to establish whether the cable has been sealed correctly. Firstly, connect an insulation tester between two conductors or one conductor and sheath. Then apply a small amount of heat to the cable behind the seal using a match or a cigarette lighter. A rapid fall in the reading confirms that the seal is faulty. If there's no change, then the seal is good. Where it's not practical to use a naked flame, a similar test can be done using a freeze spray. However, in this case, the reading will rise if the seal is faulty, and it should be noted that this increase in insulation resistance is not permanent and it will return to its previously low value as the cable returns to room temperature.
Can you repair a badly made seal?
Yes. First remove the faulty seal and strip back 3 or 4 millimeters to remove the threaded sheath. Then clean the cable and re-terminate it as previously demonstrated. Although the insulation resistance will still be low, if the end has been sealed effectively, the reading will slowly improve until it exceeds the 100 megohms.
What are the common mistakes that are made with sealing?
Well, if the pot is incorrectly filled, an air gap is left at the face of the cable. This will allow moisture from the atmosphere to travel along the pot threads into the cable, resulting in poor insulation resistance readings. Not screwing the pot on sufficiently can produce a similar result, and if the pot is screwed on too far, then a direct earth fault may result.
Is the fact that the insulant will absorb moisture really a problem?
No. Provided the cables are sealed correctly, the insulation resistance will be maintained. If the cable is damaged during installation, this may produce a potentially dangerous situation, but with Pyrotechnics cable, the insulation resistance would drop, indicating that something was wrong, so therefore it can be said that Pyrotechnics cable is actually self-monitoring.
When I was talking to Alan Walker, he made what seemed to me to be a very valid point about fixing distances.
Yes, the IEE wiring regulations allow for the fact that MI cable is more self-supporting than other types of cable, which require some 2.5 times more fixings. As Alan stated, this shows an appreciable cost saving when surface wiring Pyrotechnics cable.
Now, the latest development in the Pyrotechnics range is this new twisted pair mineral insulated cable for data communications. Is this difficult to terminate?
No. Termination of twisted pair cable is exactly the same as for standard cable, except that the conductors must be untwisted and straightened before fitting the seal.
The twisted conductor cable is normally red with 2 grey stripes. What's the significance of this?
Well, the grey stripes distinguish it from the red standard Pyro cable. The standard cables are available in bare copper or plastic coated for reasons of corrosion protection, aesthetic appearance or circuit identification.
Now, what about standards and approvals? Does BICC Pyrotechnics cable meet all the relevant national and international standards?
No other cable can provide the combination of advantages that Pyrotechnics does. Its solid construction provides an inherent flame-proof barrier. It will not burn or support combustion. It will not emit smoke or toxic gas. It will operate at temperatures up to the melting point of copper, that is 1083 degrees centigrade. It's non-aging, radiation resistant, virtually indestructible. It's smaller than other cables of the same current carrying capacity. It's pliable, waterproof and very strong, and the copper sheath provides an excellent low resistance earth continuity.
That's a very impressive list, Peter. Thank you very much for answering all those questions. By following the recommended procedures and by bearing in mind the points we've discussed, you'll find that working with Pyro 10-ax cable is both easy and straightforward. So do the job right and do it with Pyro.